This is our last example of impulse calculations. So it says, while being thrown, a net force of 132 newtons acts on a baseball whose mass is 140 grams for a period, that means time, of 4.5 times 10 to the negative 2 seconds. That seems kind of difficult to put in my calculator, so all I'm going to do is I'm going to change it out by moving my decimal 2 places to the left. So this is actually 0.045 seconds. Okay? What is the magnitude of the change in momentum of the ball? Okay. Delta P is equal to, I have a force and a time, so those are the two that I'm going to use, force and delta T. So this ends up equaling, my force is 132 newtons times my time, which is 0.045 seconds. This ends up equaling 42.43 kilogram meters per second. Okay, I put that in my calculator. I did not actually do that in my head. Okay, if the initial speed of the baseball in question is 0.0, okay, here's my initial velocity. What's its speed? This is VF, right? When it leaves the pitcher's hand. So we have our delta P. Now we're solving for final velocity. Notice, right, these are kind of all the same with these same equations. You just have to know those two, force times time and mass times change in velocity. Okay, our change in momentum, or our impulse, is 42.43 kilograms meters per second, is equal to, its mass is 140 grams, and my final velocity, that's what I want to know, minus my initial velocity is 0 meters per second, which is basically, I can just kind of take that out of the equation. Oh, wait, you guys, look. Sorry. Look, this is in kilograms. This is in grams. That's not going to work. We have to make sure that our mass is in our mass is in kilograms. Remember, there are 1,000 grams in 1 kilogram. So I need to move my decimal 1, 2, 3. So this is going to end up being, I'm going to erase that. Okay, I'm going to erase this. I think I'm going to erase that. And I'm going to rewrite my mass in kilograms as 0.140 kilograms. Now, right, you can see that these guys match units. That's a lot better, because then now I can divide both sides by 0.140 kilograms. I noticed that because what I was looking at was dividing 42 by 140, and that gives me a velocity of less than 1, which the pitcher is not pitching a ball with less than 1 meter per second speed, right? It didn't make sense to me, and so I had to go back and look and say, hey, there's something wrong. And so then I noticed that the mass, right, was different. You should be able to be like, does this make sense? Does this not make sense? Okay, so divide by 0.140 kilograms. You guys, I think I might have just done this wrong. Hold on. Let me check my paperwork here. Oh, I sure did. You guys don't trust me. Never trust me. This guy down here, my VF is equal to 42.43 meters per second. This guy, boy, I messed this up pretty good. That guy's not 42. This guy's not 42. That doesn't make sense at all. I should have known that from multiplying those guys, right? But I did it, and so I was like, I remember how to do it. I remember the number I put in. I did not remember the number I put in. This is 5.94 kilograms meters per second. That makes a little more sense. 132 divided by 0.045. Okay? Sorry, you're going to have to go and change that all. Okay, I'm glad that I noticed before I went too far. Okay, so this final velocity, right, it leaves the pitcher's hand at 42.43 meters per second. Then it says when the batter hits the ball, a net force, so new net force of 1,320 newtons opposite the direction of the ball, acts on the ball for this much time. Again, I don't love the scientific notation. That's a -3, so I'm going to go 1, 2, 3 to the left. This is 0.009 seconds. What's the change in momentum of the ball? So I have a force and a time again. Change in P is equal to F delta T. So this equals, my force is -1320 newtons, right? I used a negative because it's opposite the direction. And then my time is 0.009 seconds. This equals, I'm actually going to look at my sheet now, -11.88 kilogram meters per second. Okay, that's its change in momentum. Now, what's the final velocity of the ball if the initial velocity is the speed? Okay, so this initial velocity, right, is here. This is the not purple. This is the VI, right, for this problem here. So my change in momentum is equal to my mass. Nope, not purple. Final velocity minus initial velocity. The mass of the ball is still, so -11.88 kilogram meters per second is equal to the mass. Remember, that's 0.140 kilograms. I'm looking for my final velocity, and my initial velocity is this guy down here, 42.43 meters per second. Okay, so the first thing I'm going to do is divide by 0.140 kilograms. 0.140 kilograms. And I end up with, let's use purple, -84.86 meters per second is equal to VF minus 42.43 meters per second. Then I add 42 to both sides. Plus 42.43 meters per second on this side. And I end up with a VF of -42.43 meters per second. So same speed, but remember, because it's opposite, right? It's moving in the opposite direction. That's why it's negative. That's pretty cool. Okay, what force does the ball exert on the bat? Remember, the bat hits the ball hits the bat. That means this is Newton's. Whoops, I'm still writing in highlighter. Let's go back. This is Newton's third law. I know you guys really are excited to hear that. Newton's third law, which means equal opposite forces, equal opposite reaction, action pair. So the force of the bat on the ball is negative 1320. So this would be positive 1320. The ball is exerting on the bat. Yay, done.